At this point of the chemact8, we need to make a comparison of two different kinds of binary compounds. I'm looking at the chart or table that's found in the front page of this chemact8. We have examples of binary ionic compounds, and we have examples of binary molecular compounds. Now, one of the things that I'd like you to notice is that in binary ionic compounds, you have both metal cations and nonmetal anions present in the compound. Whereas the binary molecular compounds, yes, consist of two elements, but all the elements are non-metal. So it should be pretty easy to distinguish whether or not you're dealing with a binary ionic compound or a binary molecular compound. You may recall that I highlighted a staircase division in the periodic table: metals on the left-hand side, nonmetals on the right-hand side. This is a crucial distinction which guides us to determine whether our compound of interest is ionic or molecular. Once again, metal cation, nonmetal anion equals ionic compound. Non-metal is typically molecular compound. This pattern works at least 90% of the time. I will look at some examples further on where it doesn't work. Notice, however, regardless of if the compound is ionic or molecular, given that these are binary compounds, all the names end in the suffix "ide". Therefore, it is important to associate binary with the suffix "ide". Binary molecular compounds do, however, have a unique feature. This feature has to do with the Greek prefixes. These compounds, because they consist of both nonmetal and nonmetal elements, actually consist of atoms that are not charged, but rather the atoms are combined by covalent bonding. Therefore, the formula are not entirely predictable. There are many ways that a stable bonding configuration can be achieved through covalent bonding. As a case in point, if you combine carbon and oxygen, it's not just one compound that can form. We do not say here that oxygen has a full negative charge and that carbon always has a certain positive charge. Carbon can combine with oxygen, as it turns out, in two stable compounds. Therefore, in terms of naming, we need to use Greek prefixes to indicate which compound is present. We can't just say carbon oxide. We have to say carbon monoxide to indicate the first compound that you see here, and carbon dioxide to indicate the second compound. Phosphorus and chlorine can combine in a couple of different ways as well. Two common ways are phosphorus trichloride and phosphorus pentachloride. The only way we know that we're dealing with a compound in terms of naming is to use the Greek prefixes. Nitrogen and oxygen combine in several different ways, so again we have to use the Greek prefixes to indicate which particular oxygen compound is present. Now, there are not limitless possibilities by which nitrogen and oxygen or carbon and oxygen can combine, but we don't know which one we're working with in terms of naming until we use the Greek prefix. One final point is that you may have noticed that if there's only one of the first element in a molecular binary compound, you do not use the Greek prefix mono, and hopefully you can remember this just by thinking about it. In the case of carbon monoxide, which should be a fairly common compound for you, we don't say monocarbon monoxide. In a similar way, we don't say monocarbon dioxide. So if there's only one of the first element, we don't say mono. If, however, there's only one of the second, we do need to say mono. As a bit of practice, please consider the key question number 8, where I list a series of compounds. I'd like you to organize them into ionic compounds and molecular compounds. And then as an added feature, please apply the Greek prefixes to names of these molecular compounds. The ionic compounds consist of both a metal cation and a nonmetal anion. These here are therefore all the binary ionic compounds. For molecular binary compounds, two nonmetals will be covalently bonded. The ionic compounds here are the following: potassium chloride, manganese 2 iodide, cadmium sulfide, and lead-2 nitride. I didn't specifically ask you to name these because I'm anticipating that you already have some skill in doing this. The molecular compounds consist of all non-metal atoms, and therefore we need to use the Greek prefixes to name them. We have nitrogen trichloride, dihydrogen monoxide, also of course known commonly as water. In a similar way, a common name for H2O2 is hydrogen peroxide, but then it is systematically called dihydrogen dioxide. Nitrogen trihydride is commonly known as ammonia. So we have systematic names for all the compounds, but in some cases we have some common names. I'd like to remind you that a binary compound with a metal cation and a non-metal anion results in an ionic compound. A binary compound with only nonmetals results in a molecular compound. Moving on then is the key question number 10, in which we can compare two compounds. We've got nickel 2 oxide and we have nitrogen monoxide. These two compounds have some similarities. For instance, of course both of them are binary. They both consist of two elements. The second element is oxygen, so in both cases the suffix is oxide. However, they do differ in that the first one, of course, is ionic. It consists of both a metal cation and then a non-metal anion. The second one, the nitrogen monoxide, of course, is a molecular compound, and therefore, of course, it consists of both a non-metal and a non-metal. Because nickel in the first compound is a transition element, we have to use the Roman numeral to indicate what the charge is. In the second case, because we have a molecular compound, we have to use a Greek prefix in the name so as to indicate what the formula is. To summarize, the differences: ionic, the charges are predictable or are known from the Roman numeral, and therefore the charges will determine the formula. So if I say nickel 2 oxide, you automatically know that the formula has to be NiO. If I say nitrogen oxide, you don't know what compound I'm dealing with. And so for a molecular compound, the formula is not predictable, and in terms of the name, we need to use the Greek prefixes to say how many of each atoms. Notice that when we write nitrogen monoxide, we only use the mono in front of the second element. This short example reinforces some of the differences that we have seen between ionic and molecular compounds.